go through every single one of these. I might go quickly through the first few because I want to make sure I get to the verifying stuff, but this is the formula sheet that you guys are going to get tomorrow on your quiz, and you'll get on your test next week. All right, it's the exact same formulas that you have on the highlighted pink one, but if you look down at the bottom of the Pythagoreans, it's the 3 Pythagorean identities, but they also have them when they're moved around, so you don't have to think about algebraically moving them around. See how the first one says cosine squared plus sine squared equals 1? Instead of you guys having to think, okay, when I move the 1 over, the cosine over, what happens? I found a trig sheet that has all of it done for you, so you can just kind of see it that way. Yeah. You're going to get this tomorrow on your quiz. Your quiz tomorrow has 7 questions. All right, 4 of them are just basic simplifying, and then 3 of them are verifying. They're not terribly long. It's not terribly difficult. I didn't go through and make really, really, really hard ones for you guys. That was not the goal. It's just to make sure that you guys can apply your identities in practice. So, again, this is all of the answers and everything are in modules. You guys should have looked at it over the weekend. If you didn't at all, this might, prove to be a bit overwhelming for you as we go through it. But for this simplifying, remember simplifying, we're just making smaller. So if I look at number 1, I have nothing attached to a trig function that's squared with a plus or minus, right? We don't have any fractions or anything like that. So let's just go ahead and simplify. How do we simplify? Well, what are the 2 most basic trig functions we have? Sine and cosine. So let's change tangent. I'm going to change tangent to sine over cosine, correct? And then I have times cosine over 1, and then what happens? The cosines cancel, and you're left with what? Perfect, sine theta. If you want to change everything to theta, if you want to change everything to x, it does not matter to me. Whatever you do it's totally fine. Whatever you're comfortable with. All right, look at number 2. First question we ask, is there a trig function that is squared that's attached with a plus or minus 1? That involves 1 in cosine? Yes. All right, this is... with this trig identity stuff that I gave you, you guys don't even have to think. What can I replace 1 minus cosine squared with? Sine squared. Good. It's right up here in your identity sheet. So I'm going to replace this with sine squared. So now I have one trig function divided by another trig function. Well, those 2 trig functions happen to be our most basic. Guys, what is sine over cosine equal? Tangent. So it's sine squared over cosine squared, which is going to equal tangent squared. Everybody with me? Okay, good. Yeah.
Can you do number 9?
Yes. Can I just go in order?
Oh,
Yeah.
yeah.
All right, same thing with 3. Right, nothing's attached with a plus or minus 1 squared or anything like that. So just go to your 2 most basic. I have cosine theta over 1. And then what can I change cosecant to? 1 over sine. Perfect. So nothing cancels out. I can't just cross stuff out or anything. So when I multiply across, I get cosine theta over sine theta with, look at your identity sheets. What's cosine over sine? Cotangent. Perfect. All right, everybody with? All right, scoot down number 4. Again, nothing is being added or subtracted. We don't have anything squared attached to a plus minus 1, so let's just go through and simplify. Sine is going to stay sine over 1. I don't know why I wrote a 1. Sine theta over 1. What am I going to change secant to? 1 over cosine, okay. And then what about tangent? Sine over cosine, good. Everybody with me? Okay. I'm going to clean up the top a little bit, and I'm just going to multiply. So I have sine times 1 over cosine times 1. So sine over cosine over sine over cosine. Now, a lot of you, or some of you, at this point might have said, I didn't change the bottom, sine over cosine, I left it as tangent. That's fine. Some of you might say, well, I have sine over cosine divided by sine over cosine. Is it the same thing divided by itself? Yes. Could you cross it off right now and say 1? Yes. Could you keep change flip at this point and say sine over cosine times cosine over sine? And then cross off and get 1? Yes. Could you change sine over cosine to tangent? And then make it tangent theta over tangent theta? And then cross it off and make it 1? Yes. That's fine. As long as it mathematically makes sense. You use your identities, you follow a logical thinking path, that is perfectly fine. All right, 5. Very redundant. Same kind of thing. What can I change cosecant to? 1 over sine. Okay. And then what can I change cotangent to? Cosine over sine. Good. All I have here is a fraction divided by a fraction, so we do what? Keep, change, flip. So in this case, my sines do what? Cancel. And then I'm left with 1 over cosine, which if you look at your identity sheet, 1 over cosine is the same as, there you go. Good job, guys. Everybody okay? All right, so we get to number 6, and we're like, okay, wait, it's a little trickier now because I have a 1, a plus or minus something. I have a trig function squared. Is there a Pythagorean identity that's going to help me out here with 1 minus cosine squared? I'm going to change that to sine squared. Good. So now that we've done that, our problem becomes really easy again. Everybody agree? I'm going to keep sine squared over 1. It's divided by, change tangent to what? Sine over cosine, okay. Fraction divided by fraction, so we keep, change, flip. Now what happens? My sines cancel, and I'm left with cosine squared. Good. Everybody okay so far? All right, 7 and 8 are like the exact same thing. I'll come back to them if we have time at the end. I just want to make sure I hit on everything. How is 9 a little bit different? There's an addition sign, all right? So stuff changes, guys, when you have a plus sign. Do you have a trig function squared to where you can just go ahead and say, okay, is it attached to a plus or minus 1? It's a Pythagorean identity? No. So at this point, you guys, there's a couple things you can do. Now, again, I'm going to do it one way. You might see it another way. Some of you might want to immediately go to just sines and cosines, which is fine. Some of you might want to say, well, wait a second. Can I break this up? Can I rewrite this as tangent over tangent plus cotangent over tangent? Am I allowed to do that? Yeah. If you have a monomial, you have one term in the denominator, you can go ahead and do that. Now, what happens when I do this? What do the tangents become? They become 1, right? Everybody see that? Anything divided by itself is 1. Plus, do you guys agree with me that's just a fraction divided by a fraction? Or it's something divided by... So, go ahead. I'm going to change cotangent to cosine over sine. Or you don't have to do that. Let me go back because I'm going to keep it in terms of tangent right now, and then we'll talk about cosine and sines. What's another way I can write cotangent? Not sine and cosine, but using tangent. Look at your identity sheet. Can I rewrite cotangent as 1 over tangent? I'm allowed that to do that, right? It's on the identity sheet. And then divided by tangent over 1. So if we keep change flip, we have 1 over tangent times what? 1 over tangent. Are you guys with me? Okay. So that gave me 1 over tangent squared. Now some of you are like, why did you do that? Because, guys, is there a trig Pythagorean identity that has to do with tangent squareds and cotangent squareds? Yes or no? Yes? Okay. I'm still simplifying just in red. Again, if you went to sine and cosine, that's fine if you can get to the same answer. What's another way I can write 1 over tangent squared? I can write that as cotangent. I can say this is the same as 1 plus cotangent squared. What's the Pythagorean identity for 1 plus cotangent squared? Cosecant squared. That was a hard question. There are 15 different ways that you could arrive at that same answer. If you, at the very beginning, just said, I want to go everything to sines and cosines, you absolutely could, and you could still arrive at the same answer. It just takes a little longer to get there. It just takes a little longer to get there. And again, that's practice. You guys have to see stuff and try and practice. Now, I look at number 10. If this said 1 minus sine squared, what would you replace that with? What's 1 minus sine squared? Cosine, all right? That's not what it says, though. That is not what it says. That's when we're like, oh, man, seriously? So now I have to think a little bit. Where should I go from here? Where should I go from here? Okay, multiply by the reciprocal. That would work. 1 plus sine, right? Can you guys do that? Okay, you can use the identities to get rid of cosine. Okay, we could do that as well. What do you guys want to do? Okay, I want to go by the conjugate. All right, if I multiply here, I'm going to multiply by 1 plus. Yeah? So when I do that, I'm going to be left with cosine squared theta times 1 plus sine. Agreed? And then when I multiply all this out, it becomes 1 minus sine squared, correct? Will I FOIL? Everybody agree? Okay. Now what does 1 minus sine squared equal? Cosine squared. Look at your identities. This equals cosine squared. And now what can I do? You can cancel out the cosines and you're left with just 1 plus sine. Good. So did anyone do it a different way? If you look on the answer key, it's done a different way. What can I replace cosine squared with on top? I can replace this with 1 minus sine squared. Right? Cosine is the same as 1 minus sine. Well, if you break that down, it's just the difference of perfect squares. We're doing the exact opposite from the denominator. Right? Can't I factor that? And then what would happen with the 1 minus signs? They'd cancel and you'd be left with 1 plus sign. That's totally fine, guys. However you see it. But if you're like, okay, I'm starting off with a fraction on the bottom that has, a fraction that the denominator has 2 terms, then yes, multiply by the conjugate and it'll work itself out. All right, what about 11? Is there a trig function that has secant squared and a minus 1 or a plus 1?
Yes.
Okay, what does it equal? So this I can replace with tangent squared. You guys agree? Okay, so I'm left with tangent squared over secant squared. I'm going to change tangent to sine over cosine. You guys agree? Divided by what's secant? 1 over cosine, okay. So I have a fraction divided by a fraction, so I keep change, flip. You guys agree? What happens to cosines? They cancel. Sine squared. Anybody look at the answers, how Miss Carver and I did it last year? Same way we did one of the ones at the front. Just to show you guys, there is a million different ways to do. I can replace this, or I can rewrite this as secant squared theta over secant squared theta minus 1 over secant squared theta, can't I? I can pull it apart. It's a monomial in the denominator. I can go ahead and pull that apart. So what is secant squared divided by secant squared going to give me? 1 minus, what's another way I can write 1 over secant squared? Cosine squared. What's 1 minus cosine squared equal? Sine squared. Same thing. 2 completely different ways to look at the same problem.
We're getting all that on the...
You're getting the trig identities, yeah. Yep. All right, this is a factoring problem. I don't believe I put this on the quiz at all. This is just going to get us ready for 5-3. No, there should be a theta here. All right, it says sine squared minus 2 sine plus 1. Guys, if I said to you, what's x squared minus 2x plus 1? Can everyone in here factor this? What are your factors of positive 1 that multiply to give you 1 but add to give you negative 2? X minus 1, x minus 1. All right, this is the exact same thing. It's just a factoring problem. Remember we had the e problems like e to the 2x plus e to the x, and then you had to factor that. It's the exact same thing. What's going to go in the front of each of these parentheses? Sine. And then it's minus 1, minus 1. So that's what we're going to be doing when we get to 5-3. You're going to factor. You're going to do all the solving stuff that you've done before. Now, instead of x's, it's just going to have trig function names, and then you're going to find where that value is on the unit circle. But that's 5-3. Yeah. All right, let's go to these verifying ones. Because I really, really, really want you guys to do well on this quiz tomorrow, and I really believe that you can do well. If you didn't have the identities in front of you, I would say, yeah, I don't know, this is tough. But since you have the identities in front of you, it should be fairly easy. When I look at this first one, guys, this is a gimme. There's nothing being added or subtracted. You don't have any trig functions that are squared with a plus or minus. We don't have any fractions, nothing. All we have is a bunch of trig functions that we're multiplying together. So let's go to sine and cosine. Sine x over cosine x. That's what I'm changing tangent to. What am I changing cosecant to? 1 over sine, good. What am I doing with cosine? I'm just leaving it. Now, where are we trying to get to? We're trying to prove that all this stuff on the left equals what number? 1, okay? So what happens here? My sine in the numerator, sine in the denominator, cancel. Cosine in the denominator, cosine in the numerator, do what? So 1 equals 1. There was one step to that problem. It was go to your 2 most basic trig functions and then see what cancels out. Make sense? All right, let me get to some that are a tad bit harder. We got a tad bit harder. Which side looks a little more difficult? The left-hand side, I agree. All right, none of those trig functions are squared or attached to plus or minuses or anything like that. So now we have to do a little bit of thinking.
Please excuse the interruption.
All right, we got to do a little bit, yeah.
Question for this one. Would you be able to just like multiply them together and
Yeah, now think about this. That's a very good idea. The first thing I would tell you guys to do, right? Nothing is squared attached to plus or minus 1. I would say go to sines and cosines. But what do you notice? It's already in what? Sine and cosine. How do we always think, guys? Algebraically. So let's just said, well, it's just a binomial times a binomial, right? Am I allowed to FOIL? Absolutely. What's sine times sine? Sine squared, okay. What is sine times cosine? Plus sine cosine. What's negative cosine times sine? Minus sine cosine. And then what's negative cosine and positive cosine? Minus cosine squared. So what happens to the sine cosine stuff in the middle? It cancels out. So I'm left here with sine squared theta, whoops, minus cosine squared theta. All right, we're getting somewhere. It may not seem like it, but we are. Now, here's where you guys got to do a little bit of thinking. If there was a plus sign in the middle there, what does sine squared plus cosine squared equal? 1. But it's not a plus sign, it's a minus. So this is where you take a step back and you go, okay, where am I at? Where am I trying to get to? I'm trying to get to things in terms of what trig function? Cosine. All right, so I have these two over here on the left-hand side. Can I rewrite one of these trig functions that's not in terms of cosine? Can I rewrite it so it is in terms of cosine? All right, I like that idea. Can I rewrite this as 1 minus cosine squared? You guys agree? And then I still have minus cosine squared. That's where your negative's going to come from, Brian. Why are you allowed to do that? Because it's one of the identities. And some of you are like, well, why did you even think to do that? Because I took a step back and I said, where am I in my problem and where am I trying to get to? When I got to here, I saw that I had something in terms of cosine, but I needed something, everything needs to be in terms of cosine. So now we have just proven this, because if you add these together, what's a negative cosine and a negative cosine? How many of them do you have? I have 2 of them. So now it equals, yeah.
How did you do, like, what did you do there when you went from sine squared minus cosine squared?
I just looked on the identity sheet, and I can rewrite sine squared like this as 1 minus cosine. Those being the same thing. And the reason I did that is because I saw over here, oh, I already have one of the cosine squares. I'm trying to get another one. Good thinking, Josh. I was just kidding you. All right, next page. All right, this one. Oh my gosh. Christine, this is one you and I were talking about today. Okay, I'm not picking on you. I'm just talking, okay? Here's what Christine did. She said, okay, don't write this down because I love Christine, but I would not take this route to get there. Christine said sine squared. Did you no, she did not. I'm lying to you guys right now. Christine said, oh, I see sine squared. I'm going to go ahead and change it to 1 minus cosine squared. Is that true? Yeah. And then she said, okay, and then I have 1 plus, I'm going to change cotangent to cosine squared over sine squared. And then she went about converting, common denominator, all that stuff. Would Christine get to the correct answer? Yes. Yes. Is that going to be the shortest way to get there? No. Guys, if you start off with a trig function that's already pretty simplified, don't pull it apart and make it bigger. Sine squared is one monomial trig function. Yes, it does equal 1 minus cosine. I would say to myself, okay, that is correct thinking on Christine's part, but I want to make my life a little easier. Sine squared. I could pull it apart, expand it, make it 1 minus cosine, but that's not going to help me simplify. I'm trying to get to the left-hand side equals 1. So the first thing I do is I say, do I have a trig function that is squared that's attached to a plus or minus 1? Yes, we do. What can I rewrite 1 plus cotangent squared as? I can just write it as cosecant squared. Good. Times sine squared. See that? But your thinking was fine if you would have gone the other way. What's another thing I could do with cosecant? How can I rewrite that? 1 over sine. Now what happens to sines? They cancel, so 1 equals 1. Not to say that that can't happen. I'm not telling you that you guys, some of you might look at this and really take the long way, which is okay. It is okay, I promise. I promise. All right, what is this one? What number is this, 16? All right. We did this one 2 different ways. There's a long way and a short way. First of all, look at this. Which looks a little simpler? The left-hand side? How come the left-hand side looks simpler than the right? Because the right-hand side's got the minus sign, right? Agreed. So now you're going to look at this and you're going to go, I don't know. Where should I go with this? What should I do? Convert? Okay. What do you want to convert to? Sines and cosines? When all else fails, if you guys like, I have no idea what to do, do that. That's perfectly fine. So I have sine squared over cosine squared minus sine squared over 1. You guys agree? Okay, so what do we do now? A common denominator, which would be cosine squared. Agreed. So this needs cosine, right? So your numerator has sine squared theta minus sine squared cosine squared. Agreed? Totally. Now you're like, oh, now what? What do you notice they both have in common? They both have a sine squared, don't they? So take that out in front. And then when you divide it out, sine divided by sine is 1 minus, I'm left with cosine squared over cosine squared. Everybody with me? Okay, what else can we do? What's 1 minus cosine the same as? It's on your identity sheet. What's 1 minus cosine the same as? Sine squared, okay. Now, from this point, you could do a lot. You can say this is sine to the 4th over cosine squared. Do you agree? Sine squared times sine squared? What's up?
Where did the cosine go? Like, you went from sine squared minus sine squared times cosine squared, then you turned it into sine squared and then 1 minus cosine.
Okay, so if you divide out a sine squared, right, you have sine squared out in front, you took it out. So then you say sine squared divided by sine squared is 1. And then this sine squared and this sine squared become 1. So then it's just minus cosine squared. What else could I do from this point here? How could I rewrite that? Can I split it up? Can I split it up as sine squared over cosine squared times sine squared over 1? Which sine squared over cosine squared becomes tangent squared times sine squared, which is where we were trying to go over there. Now, if you didn't see that, if you got to this in the blue, and then you're like, wait a second, now what do I do? When we get stuck on one side, what did I tell you could do? You can go and work on the other side if you need to. Give yourself a little guide. You get to this point, and you're like, okay, this is as small as I can go, I think. I don't know what else to do. These two things are the same. But I don't know that. I don't see it. So come over here. What can I change tangent to? Sine squared over cosine, right? Times sine squared over 1. If you multiply those together, do you get sine to the 4th? Over cosine squared. And then you're at the same spot as there. You absolutely can do that. Can you go to tangent? No, because it's all multiplying, so that's a good question. If it was a plus sign, then yes, but since it's multiplying, think about it. If you took it off and went like this, and then this was sine over cosine, when you multiplied them, it would be sine to the 4th over cosine to the 4th. Since it's multiplying, the one goes underneath one of them. Now, if you look on if you look on the answers that I posted, there's 1 or 2 other ways to do it. I think Ms. Carver did it. She changed the sine to cosine and then went to tangents and she looked at it on the other side, which was actually a lot faster. If you look the way her brain worked.
So
Question.
when you're multiplying, like for example,
The denominator goes with just one of them.
yeah, so like in the example that you did where you did like the cosine, like the sine minus sine times cosine.
Mm-hmm.
To like not get confused, you can just put them together. So it'd be like sine squared theta cosine without parentheses. So you're like just factoring it out of that huge one. So that's why you just got that together.
Yep. All right, 2 more. 17. Good old 17. We like these ones when they equal 1. Again, there's a couple different ways to do this. You can look at it however you would like to. Anybody have any thoughts? Everything to sine and cosine? Okay, perfect. So secant is going to become what? 1 over cosine over cosine. Agreed? Minus, now what happens? Sine over cosine divided by cosine over sine. Okay, there's a lot going on here. I just have a bunch of fractions divided by what? Fractions. Are we allowed to simplify within our fractions?
Yes.
What can we do? Let's keep change flip here. So in blue, I'm going to say 1 over cosine times what?
Cosine, like 1 over.
1 over cosine, which gives me 1 over cosine squared. Okay. Everybody agree? We okay? All right, minus. What do I do on this side? You keep change flip, so different color, do it in red. So you have sine, yeah, sure, times, what happens here when I flip?
Sine over cosine.
You were hoping they'd just cancel?
Yeah.
All right, so I have sine squared over cosine squared, right? Okay, now think, where are we trying to get to? We're trying to get to, say, 1. Okay. Let's think algebraically. If you have fractions and you're adding and subtracting them, they have to have a what? Do these already have a common denominator, guys? Look, they're the same, isn't it? So can't you just rewrite it over one denominator? What's your numerator? 1 minus, yeah, I'm getting ahead of myself. 1 minus sine squared. All right. Look on your identity sheet. Does 1 minus sine squared mean anything to you? 1 minus sine squared, I can replace that and make it cosine squared over cosine squared. What happens when you have the same thing divided by itself?
1.
It equals 1. Which is where we were trying to go. Yeah. Sure.
Thank you.
Now, if you look on the answers, yeah, I mean, I don't think we went a long way about it. If you look on the answers, I think the second way Ms. Carver did it was a step shorter, but not really that big of a deal. I think if all else fails, guys, and you get stuck on something, just convert to sines and cosines. All right, 18 is a bit of a doozy. 18 is a bit of a doozy. I don't think there's anything on your quiz that's as involved as this, but it's good to kind of think a little bit here. All right, which side looks more difficult? The left. All right, so we had a problem like this before where we just said, oh, we'll just go ahead and multiply it, right? Is it going to help us if we FOIL this? Now, some of you are like, how do you know if it's going to help or not? Well, think about it. Just look, guys. The last one had sines and cosines. So when we multiplied them together, we got sine squareds and cosine squareds. When I multiply here, sine tangent's not going to help me. Cosine cotangent's not going to help me. So when all else fails, where should we just go? Convert to sines and cosines. It might make your life easier. So this is just this first example, not first example, but this first one is sine theta over 1 plus cosine theta over 1, correct? Okay, so here. And then what does this become? Sine over cosine plus cosine over sine. Okay. Everybody with me? Any idea of where to go?
You want to go to the sine over cosine and find a common denominator.
Okay, you want to get a common denominator here? That's fine. What's our common denominator here? Sine cosine, okay. So, my first fraction has, what does it need? What's it missing? All that good stuff. Well, if I want the denominator to be the same, what do I need to multiply by? Which one? Were you talking about the one on the right?
Yeah.
Oh, okay. That's fine. Guys, I'm letting you guide me. I've already done it 2 different ways on the answers. So you want to work on the one on the right? This one over here? Okay, so cosine sine. That's fine. So then this one needs sine, and this one needs cosine? Is that what you're telling me? So you're going to have sine squared plus cosine squared? Okay, that's fine. So then I still have my sine theta plus cosine theta. Okay, so now what? What's sine squared plus cosine squared equal? Agreed. That had to have helped somehow, right? And then over here we have now what? Mm-hmm. How do we think, guys? We think algebraically, right? If you're adding fractions, they have to have a common denominator. Do you guys agree that this right here in pink is sine theta plus cosine theta over what? Over 1, right? Times 1 over cosine theta times sine theta. Right? It's just two. That's it. Can I just cross off the sines and the cosines?
No,
Why not?
because you're adding them on the
Excuse me. Why can I not just cross them off, guys?
because one's adding
Because one's adding
and
and the other one's not. Correct. Can I multiply these two fractions together, though? How do you multiply fractions? You multiply numerators and denominators. So when I multiply the numerator, sine theta plus cosine theta times 1 just gives me sine theta plus cosine theta times 1, right? Over cosine theta times sine theta. We haven't done anything. We have not changed, excuse me, the values of anything. We just said, hey, let me go ahead and multiply fractions together. Everybody with me? Okay. Now what can I do? Think algebraically. How can I split them, Melissa? Sine theta over your denominator, cosine sine, plus cosine over your denominator. Now, why is this different from the last one we did where we didn't use both the denominator in both places? What were we doing in that last problem? Multiplying. What are we doing in this problem? Adding. All right, you've got to be able to think algebraically, guys. You have to know your algebra rules. If you are adding fractions, see how the numerator has an addition sign? So you can rewrite each term over the whole denominator. If you're just, if you're multiplying, you can't do that. Now can we simplify within our fractions? Yes. What happens in the left one? Sines cancel, so you're left with 1 over cosine, which becomes what? Secant. What happens on the right? Cosines cancel, you're left with 1 over sine, which becomes cosecant. Which is where we're trying to go. That is a very difficult problem. I understand that. I do not believe there's anything on your quiz that's even remotely close to something that hard. But there's an alternate way that Miss Carver and I talked about last year, or at the very beginning, once we went to sines and cosines in that first step in pink, and then we foiled. You can foil fractions. It's allowed. My suggestion to you guys, I don't think anybody's going to memorize any of this. Try this again on your own, blank. Try your WebAssign, blank. Google verifying trig identities. A million things will pop up. Some of them that pop up are really hard. We don't get into those really, really hard ones. But understand, you're going to have your identities tomorrow, and you guys are going to be okay. I promise. Then we have one more section to do, and then we're done.